So today we're going to talk about what happens when you're multiplying numbers that have the same base, and it's actually pretty simple. All you're going to do is add the exponents to get and then on your notes it's a typo, it should say product, not quotient. Right? Product is the answer to a multiplication question. So when you're multiplying numbers that have the same base, right, the base here being a, all we have to do is add the exponents, and here's why. If I said I have a to the 5th power, that means a times a times a times a times a, right? 5 times. And now we're multiplying it by a to the 3rd, which is a times a times a. What do I have down here? I have 1, 2, 3, 4, 5, 6, 7, 8 letter A's, even though that one looks like the number 9. It's an A, right? So I have a to the 8th power. All I did was add together 5 and 3 to get 8. So, for example, x to the 4th times x to the 7th would be x to the 11th power. X to the 3rd times x squared, x to the 3 plus 1 plus 2, x to the 6th power. Okay, let's change this to a multiplication symbol. M to the 5th times m to the 4th, m to the 9th power. X to the 6th times x would be x to the 7th. So why don't you pause it for just a second. I'm going to fix my phone here. Okay, and do that bottom row right here, and let's then, so pause it, do those 4 questions, then come back and we'll check your answers. Okay, this one you should have 4.5 to the 5th, x to the 4th, 3 to the 11th, and then y squared. Okay, let's talk about when you have 2 numbers that are scientific notation and you are multiplying them together. Okay, what you're going to do first is multiply together the numbers that are not powers of 10. So I'm going to multiply 2 times 4. So 2 times 4 is 8. And then I have 10 to the 3rd times 10 to the 4th. Think about what we did up here. That's 10 to the 7th. Okay, let's look right here at this one. I have 5.5 times 10 to the negative 7th times 1.1 times 10 to the 4th. So I'm going to do 5.5 times 1.1. 1 times 5 is 5. 1 times 5 is 5. Put a 0 to show I was there. 1 times 5 is 5. 1 times 5 is 5. So that's 5, 10, and a 6. Then there should be 2 numbers behind my decimal. So I get 6.05 times 10 to the negative 7 plus 4 is negative 3 power. Let's look down here at this one on the bottom left. So I have 9.2 times 10 to the 4th times 3.1 times 10 to the 5th. So I'm going to multiply 9.2 times 3.1. I'm going to do that first. 1 times 2 is 2. 1 times 9 is 9. Put a 0. 3 times 2 is 6. 3 times 9 is 27. So that's 2, 15, 8, 2. And then I should have 2 numbers behind my decimal. So 28.52 times 10 to the 4 plus 5 is 9. Now, here is the problem. That is not written in correct scientific notation, right? Because 28.52 is too big. So what I need to do is I need to move my decimal from here to here. And when I do that, I'm going to add a power of 1. That is how I'm going to move that decimal, by adding a power of 1. Okay, so I'll explain that in just a second, but let's go ahead and write it down. So now my answer is 2.852 times 10 to the 10th. That is correct scientific notation. Okay, so really quickly, let's just talk about what I did over here. Okay, if I gave you 25 times 10 squared, right? That's 25 times 100. That's 2,500. So if I moved the decimal point over 1, That's 2.5. That means essentially I have to move this decimal point over by adding a third power of 10. 10 to the third, 10 times 10 is 100. 100 times 10 of this is 1,000. 2.5 times 1,000 is 2,500. That's how that works. Okay, and then let's do this last one together. 4.5 times 10 to the 8th times 4.2 times 10 to the 5th. So the first thing I have to do is 4.5 times 4.2. 2 times 5 is 10. 2 times 4 is 8. Plus 1 is 9. Put a 0 to show I was there. 4 times 5 is 20. 4 times 4 is 16. Plus 2 is 18. 0, 9, 8, 1. Two numbers behind my decimal. So 18.9 times 10 to the 8 plus 5 is 13 power. But now what I should recognize is that this is not correct scientific notation. So I need to move my decimal one place, which means I'm going to add to my power of 10. So what I end up with is 1.89 times 10 to the 14th.